Alright, got another progress video for the 3D printer. What you're looking at here is the bed, the platform where you build all your parts on. And it's a heated bed, so that it prevents warping and basically better adhesion, stuff like that. So anyways, just to walk you through it, I've seen it before, the aluminum plate. Put grooves in it, and those have nichrome wire running through it, 24 gauge. There's 4 parallel circuits. Each one has 52 inches of that nichrome wire, which is about 7.3 ohms each. When you put it in parallel, the whole total ohmage is like 1.8 or something. So basically when you put 24 volts into it, it's drawing lots of current and dissipating lots of heat, and that's what I like. I don't know if you can see it, but underneath around the nichrome as ultra copper Permatex gasket sealer, and that is just to help hold it in place, one, and also provide a little bit better heat transfer. It's not great, but it's better than air, and it's way cheaper than some like thermal epoxies that you could use. Then I have a fiberglass paper mat over it to prevent heat from being lost out the bottom. And then all over everything is capped on tape holding it together. And that's just a high temperature polyamide tape, which is what everyone uses for this sort of thing because it works awesome. Alright, well, I will start it up for you. First my reference temperature. That's going off of a thermocouple just taped to the top of the bed. Oh, then I forgot to mention the onboard temperature is a thermistor down in here. It's a 100K NTC thermistor rated at 300 degrees Celsius. And it goes to the board, which you haven't seen yet, is my new driver board. And I'm going to tell you about that in a second. So first I will connect manual control, get the temperature curve going. Alright, what are we reading here? 24.12, 24.8. I mean, I'm happy. Within a couple degrees, I'm pretty happy. It's not like, we're 2 different types of sensors, and the thermistor's on the low end of its calibration scale, so it's not an accurate range, and I'm not sure how that thermocouple is, but anyways, it's pretty good. So, start it up. And as you can see, it draws about 13 amps, which is a pretty decent amount, which equates to about 300 watts on this 24 volts. So yeah, it'll take a little while to heat up, but while it's doing that, I'll show you the driver board. Just got done making this. It's pretty much, it's controlled by an Arduino Mega, which is a lot of hobby 3D printers use. It's actually kind of based off the Ramps platform, which Ramps is a driver board that like a lot of hobby 3D printers use. It has its own stepper motor drivers and heater, everything. It has its own system. I wanted to make this a little different, so I made my own. Plus, it's cheaper. So some of the things I added are I had 5 stepper driver circuits. That's because I might want to have 2 extruders. So you have X, Y, Z, and then the 2 extruders. So I can play with different color filament, different types of filament. We're actually, I think we can make conductive filament, which would be very interesting. So you can print your own little circuit wires inside the plastic. That'll be fun to look forward to. Anyways, these are unipolar drivers versus the more common bipolar. They are a little bit cheaper, and these ones specifically can handle 3 amps to the stepper motors, which is a lot more than the other ones in the standard, like RepRaps. The really common ones, the Pololu driver, which is a bipolar, I think it's like maxes out at 2 amps. And it's like they're like $10 each for this setup, but I opted to make my own. And then I also have beefy, big ass MOSFETs for all the heating circuits. And I kind of wanted that because my heated bed draws a lot more power than I think most. And I just wanted something beefy. And these are beefy. And like I can see, it's drawing 13 amps and it's pretty cool to the touch. It's not even warming up, which is what I like to see. Other than that, these are RJ11 or RJ12 probably more technically, sockets, and I'll have my limit switches plugged into those. Over here, this blue wires is, like I said, my thermistor. There's another port for a thermistor here. This is a 12 volt in case I want to run like a cooling fan for something or some external power. This one here is set up so that I can have some remote thermocouples, and I might run a thermocouple on the extruder because it works better at higher temperatures. So I have to, you know, make a daughter board for that or whatever to drive that. Yeah, let's see what else is on the other side of here. Nothing really too exciting. Beefed up the traces where all the current's going through. Some of it looks kind of, some of the soldering's a little hacked because one of my first etching, like me actually etching, and I kind of messed it up. I didn't expose it long enough or something, so a lot of the traces weren't separated, so I had to do a lot of razor blade action to get it to work. But it all works now. So yeah, that's about it on that front. How's this coming? Oh yeah, we're at 66. Yeah, it's not tracking by a couple degrees. I don't know what. Not a big deal. But yeah, this baby is toasty. And it's working awesome. So that's it.